When we name branched alkanes and halogenoalkanes, the substituent groups are named alphabetically before the main alkyl name. So for example, below you can see you have 4 carbons in a row, which makes it butane. If you look at the chloro group, you could think it's on either carbon number 4 or carbon number 1, and we go for carbon number 1 because that is the lowest number. If we look at this example, we have 2 carbons in the chain, so that is ethane, and we have a bromo group on the first carbon, so that becomes 1 bromoethane. Sometimes the 1 is dropped because it can only be on the 1 position. In the next example, you have 3 carbons in a row, so that is propane, and this time the chloro group is on carbon number 2, so it becomes 2-chloropropane. In this case, you have to be careful looking for the longest chain. Initially, it looks like you have 5 carbons in your longest chain, but actually if you draw across, you will see that the chain actually has 6 carbons. That makes it hexane, and you have 1 methyl group branched. You then have to look at the numbering. If you go from the left-hand side, it would be on carbon number 3, and if you go from the right-hand side, it would be carbon number 4. So we pick 3 because that is the lower number. So that molecule is 3-methylhexane. In this example, we have a branched structure and also a bromo group on it. So again, you look for the longest chain, and in this case it is 5 carbons, so it is pentane. And then we number where we find our methyl group and our bromo groups. So in this case it would be 2,3-dibromo, 3-methylpentane. The bromo comes before the methyl because B comes before M in the alphabet. We go for 2, 3, 3 instead of 3, 4, 3 because we go for the lowest numbers. You studied alkanes at GCSE level, and we looked at examples where we had the double bond between carbon number 1 and 2 and in but-1ene, and then the double bond between carbon number 2 and number 3 in but-2ene. So when we are naming our alkanes and we have more than 2 carbons, we have to say where the double bond appears. It is important to number your carbons, and you pick the number where the double bond is and you pick the lower number. Once you have named your alkane, those numbers stay on those carbon atoms, so you can't go from either side when you're numbering anymore. The alkane, the double bond position, indicates the carbon number. We're going to look at some other functional groups. In this case, instead of putting the name before the alkane chain, we are going to change the ending of the alkane chain. You have seen this example in GCSE when you studied your alcohols, where you had, for example, shown propanol, and in this case propan-1-ol, because the OH group is on the 1 position. So we change the name, the ending of the name of the alkane to ol to signify that you have an OH group present. We're going to look also at carboxylic acids, where the ending changes to oic acid, and we're going to meet some new molecules you haven't met before. So we're going to meet the functional group, the aldehyde functional group, and also the ketone functional group. We will also have a situation where you will have more than 1 functional group in a molecule. In that case, you have to prioritize your functional groups. The functional group that is highest priority that we always name is the carboxylic acid. So it has the highest priority, and you can see the lowest priority are the halogenoalkanes. Here is an example from GCSE. This is an alcohol. It has 3 carbons in the chain, so meth, eth, prop, So it's going to be propanol, but we need to give more information than that. We need to say where the OH group is. So we need to put in our number, which is propan-1-ol. When we have a letter and then a number, we put a dash between them. In this case, the carbon chain is still 3, but the OH has moved from carbon number 1 to carbon number 2. So this is named as propan-2-ol. As you can see, propan-1-ol and propan-2-ol will have the same molecular formula, but they are different molecules and they will react differently. We call these isomers, and we're going to meet that later on in the topic. The next functional group we're going to look at is a new one called the ketones, and it is a C double bond O, and it is found in an alkyl chain. In this case, you count that carbon as one of the carbons of the chain. So there are 6 in this chain. I'm going to use the name hexane. I'm going to drop the last E and add in ONE to give me hexanone. However, I also need to say where my carbonyl is, and I find it on carbon number 2. So it becomes hexan-2-one. The next functional group we're going to look at is the aldehyde group. It's quite similar to an acid group, and it's always found at the end of a chain. It's a C double bond OH, or you sometimes see it written as CHO. That is always carbon number 1. So when I count my carbons in the chain, I have 6. So again, I'm going to use hexane, and I'm going to drop the final E and add Al, and I get hexanal. I don't need to put a number because the aldehyde group, the CHO group, is always on carbon number 1. You have met carboxylic acids in GCSE level, and they have the ending oic acid, where you drop the final letter and add on oic and acid. So if we look at the example, you've got 3 carbons in a row, so meet these so propanoic acid. The acid carbon is carbon number 1, so that means the bromo is on the 3 position. So it becomes 3-bromopropanoic acid. So our acid carbon and our aldehyde carbon are always carbon number 1 when we are naming. What happens if you have more than one functional group? In this molecule, you have a branch, you have chloro groups, and you have an alcohol group. If we look at our priority, the alcohol group is the highest priority. So I'm going to start by naming this molecule using the alcohol group. And when I do that, I get butan-2-ol. I'm now going to look at my branch and look at the chloro groups. Now that I have named it butan-2-ol, the carbon that the OH is on is carbon number 2, and I name everything relative to that. The methyl group then is on carbon number 2, and the chloro groups then are on carbon number 4. That means that the molecule becomes 4,4-dichloro-2-methyl-butan-2-ol. I put the 4,4-dichloro first because C comes before M in the alphabet. If I look at this molecule, I have both an acid group and an alcohol group. An acid group is my highest priority group, so I'm going to name that first as my acid. I have 4 carbons, so it's going to be butanoic acid, and I now then have to say where I find my alcohol group. My alcohol group then, the name goes to the beginning of the name, and it becomes 3-hydroxybutanoic acid. The reason why it's on the 3 position is because the acid carbon is always carbon number 1. So when you have an alcohol group and a higher priority group, the alcohol group becomes the hydroxy group. If we look at the next molecule, we have a branched and we have bromo groups and an alkene. I'm going to start by naming the alkene, and I have 4 carbons, So that's going to be bute, and the double bond is between carbon number 1 and number 2, so it's going to be bute-1-ene. I now have labelled my carbons, so I know that I have a methyl and a bromo on carbon number 3 and a bromo on carbon number 4. So the molecule becomes 3,4-dibromo 3-methyl bute-1-ene. Just check why you have your commas, because you're between two numbers, and your dashes are always between a number and a letter. This is a molecule that we've met before, and it is a 6-membered ring. It's got 6 carbons, so it's going to be hexane. But we need to say that it is cyclical, so we call it cyclohexane.